Okay, for question 5 on the test review, researchers studying acid rain measured the acidity of precipitation in a Colorado wilderness for 150 consecutive weeks. Acidity is measured by pH. Lower pH shows higher acidity. The acid rain researchers observed a linear pattern over time. They reported that the least squares regression line, pH, equals 5.43 minus 0.0053 times weeks. Now, for this one, the linear regression is already done, so we just have to work with it. So what we have, first of all, be very clear, our input. Our input is weeks. So if this was like y equals 5.43 minus 0.0053x, weeks is x. Weeks is x. You tell me how many weeks, and my output, my y, is going to be pH. So be very clear which is your input, which is your output. That is the very first thing that we need to do. What is the input? What is the output? Very first thing that we need to do. So we're clear that the weeks is x and the output y is pH. Now, in order to draw, we're going to have to sketch. Well, they don't give me the data. Normally we know that, okay, x is weeks, that goes on the x-axis. Y is pH, that goes on the y-axis. Now, since they don't give me the data, how can I figure out where to start, where to end? Well, there's clues. So for example, it's 150 consecutive weeks. So for weeks, I'm going to start at 0, I'm going to go to 150, and then maybe I'll count by 50s. Okay, I can even count by 25s if I like. Then for pH, we have to really look for the clue. Well, notice we have y equals 5.43 minus 0.0053x. Well, the 5.43, that is your y-intercept. And then notice that the slope, negative 0.0053, is negative, so it's going downward. So if 5.43 is where it's starting, I'm going to go above that at 6. And since it's going downward, I'm going to go down to 0. And let's say we'll count by 1s. Now a different scale would work, but this works as well. So we're going to go to our calculator and we're going to sketch just a line. Again, we don't have the data, we have just the line. We don't have the data, we just have the line. So we go to the calculator, we're going to go to y equals. We're not plotting any points, so if you have plot 1 on like I do, I'm going to go up to plot 1, hit enter, and then in y1, I'm going to put the equation. 5.43 minus 0.0053x. Then I'm going to go to window, and the window we created. We're going to go from 0, x minimum, 150, x maximum, scale, I counted by 50s, y minimum, 0, y maximum, 6, and y scale by 1s. Then when I hit graph, we see the line. It's starting at 5.43 and it's going downward, negative slope. Okay, so it's starting at 5.43 and going downward. Okay, so now we can talk about it. When we talk about it, is the association positive or negative? This would be negative. The line's going downward, right? Slope is negative. What does association mean? It means as weeks increase, the pH decreases. And now we're going to explain the slope and the y-intercept. Now remember, the slope is the number in front of x. Slope is the number in front of x. So that would be negative 0.0053 over 1. And the y-intercept is a number on its own, 5.43. So how do you explain a slope? It's always y over x. Y is pH, x is weeks. So if I wrote this in a sentence, every 1 week, the pH decreases 0.0053. Notice I don't put decreases negative. Decreases means negative. And then how do you explain a y-intercept? A y-intercept is when x is 0. And what is x? X is weeks. So at week 0, the pH is 5.43. So basically it's saying your pH starts at 5.43 and every week the pH decreases 0.0053. Now, we're going to use that line to answer the next questions. Remember, our line was y equals 5.43 minus 0.0053x. So, in the first examples, we're given weeks. So they're going to go in for x. Now, you can type that in the calculator, or we can use the table. Both ways are good. I'll show you both. So if I go to the calculator, I could type in, hit second mode to go to the home screen, 5.43 minus 0.0053 times 1, and we get the answer of 5.42, let's call it 5.42. Now, a little calculator trick, so I don't have to type it again. If you hit second enter, you get it back, and then we can change it to 150, and you get 4.64. Okay, we would write this in a complete sentence. At week 1, the pH is predicted to be 5.43. At week 150, the predicted pH would be 4.64. Now, we could also use the table feature for this. If we go to the calculator, we already have y equals 5.43 minus 0.0053x. Make sure your your table set is correct by hitting second window for table set. Make sure it's ask auto, enter on the ask, enter on the auto. Then when you go to the table feature, second graph, you can plug in 1 and you can plug in 150 and you get the same answers. Okay. Now for the last ones, they give us pH. So the pH is going to go in for y. So 5 equals 5.43 minus 0.0053x. I'll leave a little space. And then 4.75 equals 5.43 minus 0.0053x. So we're going to have to do a little bit of algebra. So for the first one, we're going to subtract 5.43, subtract 5.43. We get negative 0.43 equals negative 0.0053x. Divide by negative 0.0053. Divide by negative 0.0053. We get x equals, we'll put that in the calculator, second mode, negative 0.43 divided by negative 0.0053, and that gives you 81.13. So that would be prediction of 81.13 for the pH to be 5. And then for the second one, same algebra, we would subtract 5.43, subtract 5.43, 4.75 minus 5.43 gives you negative 0.68 equals negative 0.0053x. Divide by negative 0.0053. Divide by negative 0.0053. You get x equals divided by negative 0.0053. And that gives you 128.3. So again, a complete sentence. For the pH to be 5, the predicted week would be 81.13. For the pH to be 4.75, the predicted week would be 128.3. Now, again, those are predictions based on data. Now, could we do this in the calculator? A couple different ways. Once you find the answer like 81.13, we can go to the table feature, second graph, put in 81.13, and it should give us pretty darn close to 5, which it does. And the other answer, 128.3, 128.3, put that in, and that gives us 4.75. So we can check our work right afterwards. Another way to do this, it's a little more complicated, but it's nice to know. If you go to y equals, put y in for 5, y2 of 5, that's the first one, y equals 5. Hit graph, you can see where the two intersect. Hit second trace, number 5 for intersect, and then hit enter 3 times. Enter. You get 81.13. The second one was when y is 4.75. So we go to y equals, change y2 to 4.75, hit enter, hit graph, same steps, second trace, number 5 for intersect, hit enter 3 times, enter, and you get 128.3.